Hello everyone, welcome to NG's Corner for Nurses. Hope all of you are doing well. Today we are here with the last part of the basics of ECG interpretation. In this video, we will cover the axis deviation. In this session, we will know what is cardiac axis and the methods of axis interpretation. Let's know what is cardiac axis. Cardiac axis represents the sum of depolarization vectors generated by individual cardiac myocytes. Clinically, it is reflected by the ventricular axis. An interpretation relies on determining the relationship between the QRS axis and the limb leads of the ECG. Since the left ventricle makes up most of the heart muscle under normal circumstances, the normal cardiac axis is directed downward and slightly to the left. The QRS axis between minus 30 degree and plus 90 degree. Here the purple color denotes the normal axis. And the abnormal axis deviation indicating underlying pathology, and it is demonstrated by left axis deviation, right axis deviation and extreme axis deviation. First is left axis deviation when the QRS axis is less than minus 30 degree. The green color is denoting the left axis deviation. Next, right axis deviation when the QRS axis is greater than 90 degree. The sky color is denoting the right axis deviation. And the extreme axis deviation when the QRS axis between minus 90 degree and 180 degree. The yellow color is denoting the extreme axis deviation. This extreme axis deviation is also known as northwest axis. There are several complementary approaches to estimating the QRS axis, and it can be done by these three methods: the quadrant method, three-lead analysis method and isoelectric lead analysis method. Now we will discuss each method in details. So first is the quadrant method. The most efficient way to estimate axis is to look at the lead 1 and lead AVF. Examine the QRS complex in each lead and determine if it is positive or isoelectric or negative. A positive QRS in lead 1 puts the axis in roughly the same direction as lead 1, and the positive QRS in lead AVF similarly align the axis with lead AVF. So combining both colored areas, we can see in the picture that the quadrant of overlap determines the axis. So if lead 1 and AVF are both positive, the axis is between 0 degree to plus 90 degree. That is the normal axis. This is the summary table of quadrant method. By the help of this summary table, we can determine the axis deviation of a particular ECG. Next, coming to the second method, the three-lead analysis method. Next, we add a lead 2 to the analysis of lead 1 and lead AVF. So, a positive QRS in lead 1 puts the axis in roughly the same direction as lead 1. A positive QRS in lead 2 similarly aligns the axis with lead 2. And we can then combine both colored areas and the area of overlap determines the axis. So if lead 1 and lead 2 both are positive, the axis is between minus 30 degree to plus 90 degree. That is normal axis. The combined evaluation of lead 1, lead 2 and AVF allows rapid and accurate QRS assessment. The addition of lead 2 can help determine pathological LED from normal axis or physiological LED. So, LED means left axis deviation. So lead 3 or lead AVF can both be used in 3 lead analysis. In 3 lead analysis with lead 1 and lead 2, we can use lead 3 or lead AVF. This is the summary table of 3 lead analysis method. By using this summary table, we can determine the axis deviation of a particular ECG. Next, coming to the third method, the isoelectric lead. This method allows a more precise estimation of QRS axis using the axis diagram below. If the QRS is positive in any given lead, the axis point is roughly the same direction as this lead. And if the QRS is negative in any given lead, the axis point is roughly the opposite direction to this lead. If the QRS is isoelectric, that means euphasic, then in any given lead, a positive deflection equals to negative deflection, and the axis is at 90 degree to this lead. These are the steps of determining the isoelectric lead method. Let's see an example. Here in this ECG, we will determine the axis deviation. We are using the second method, that is the 3 lead analysis method. In this ECG, we can see in lead 1, the QRS complex is positive. In lead 2, the QRS complex is negative. And in lead 3 or in lead AVF, we can see the QRS complex is negative. Now, by taking help from the 3 lead analysis summary, we can determine that the axis deviation is minus 30 degree to minus 90 degree. So, in this ECG, there is the left axis deviation. Let's see another example. Here we will determine the axis deviation by using the first method, that means the quadrant method. In this ECG, we can see the lead 1 is negative and the lead AVF is positive. So, by taking help from the quadrant method summary table, we can see here the axis deviation is plus 90 degree to 180 degree. So, in this ECG, there is right axis deviation. If this content is useful for you, then please put a like and share it with others. And for getting more videos like this, you can subscribe my YouTube channel NG's Corner for nurses. And for any suggestions or for any queries, you are most welcome to comment. Thank you for watching.